Course 2, this is lesson 98. Can you believe it? We're almost at 100. This is all about scale and scale factor. You know, when you make a model of something, it's to scale. That means it's going to look exactly like the larger thing, only tinier, right? But in order to do that, you have to have a scale factor. Secret word, fish. Okay, so just like similar triangles, scale models and drawings are also similar shapes. Therefore, the lengths of corresponding parts are proportional. So, scale is stated as a ratio. Okay, let's see what we mean by that. Example 1, a model airplane is built with a scale of 1 to 24, or you could think of it as a fraction, 1 over 24. If the wingspan of the model is 18 inches, the wingspan of the actual plane is how many feet? Well, the scale, the actual plane, is 24 times larger than the model, 1 to 24. But the model is in inches, and our answer needs to be in feet. So we can do this two different ways. First, we can say, all right, well, we're going to take 18, because that's my model, 18 over 24, or 18 times 24, because it's 24 times larger, over 12 inches. Right? So then I will end up with feet. So I can reduce here. So I have 18 times 2. I get 36 feet. Or if your brain wants to think of it this way, this is the way my brain likes to work it. My model, it's 1 to 24. My model is 18 inches. So what is my object? So now I have 1 over 24 equals 18 over x. I would get 1x equals 432 inches. And then I'm going to use a unit multiplier to convert inches to feet. So, inches, 1 foot, right? We all know how to do those. So you cross off the inches, multiply across, divide, and guess what? You get the same answer. So whichever one your brain likes, that's the one you should use. You could also graph the results. Put the model in inches over the actual size in feet, and look, you get a nice straight line that includes the origin. Ding, 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 ding. So they're directional, proportional, whatever it is. Direct proportion. All right, so again, 1 inch of the model, 20, it equals 24 inches of the plane. 24 inches is 2 feet, so that's why I put this in feet. So you get 1 equals 2 feet. 2 equals 4 feet, on and on and on and on. That's how you get your nice straight line. All right, let's just go to another example. Sophia is making a model car with a scale of 1 to 36. If the height of the actual car is 4 feet 6 inches, then what is our model going to be? Because now we're just doing the other way around. So we convert feet into inches. So we have 4 feet 6 inches. I want this all in inches. So 4 times 12 is 48 plus 6. So I have 54 inches. Okay? Now I have this converted to inches. Now I can put this in my ratio box. My model, the scale is 1 to 36. I don't know the size of my model, but I do know the size of the actual car is 54 inches. Now I have my proportion. Cross multiply. I get 36x equals 54. X equals 54 over 36, and you can reduce that to 3 over 2, or 1.5 inches. All right, you could have also divided that 36 into 54 and gotten the same thing, but I could reduce that, so I did that instead. See, there's all different ways you can do math. It's just which one makes more sense to your brain. All right, then we have this. Sometimes you don't even have to do any actual math. You can just use your brain. So instead of a ratio, think factor multiplied with 3 equals 15. Which one? 3 times what equals 15? 5. So that means 7 times 5 will be this number. So n equals 35, because they are proportional. Yes? Yes, Mrs. Valen, you're right. Of course I'm right. All right, example number 4. Here we have triangle, triangle A, and triangle B. And they've given us all the measurements. Oh, look at that. How wonderful. But now we have to calculate the scale factor. I want to know, well, what is the scale? What if I want to make it at home and use different numbers? I want to know the scale. So this is easy. we're going to get the dimension of triangle A times the scale factor will equal the dimensions of triangle B. What? Just watch. I'm going to choose two corresponding sides. Remember, we've done that before. So I am going to choose 20 and 25. So to get the scale factor, all I'm going to do is triangle A times scale factor. So 20 times F for scale factor equals 25. Now I'm going to isolate F. So F equals 25 over 20, or 5 over 4. Or I could have done 12. Where's my 12? 12 to 15. You're going to get the same thing. 12 times a factor equals 15. The factor is 15 over 12, or 5 over 4. Or what if I didn't do that one? What if I wanted to do 16 is to 20? 16 times a factor equals 20. The factor is 20 over 16, or 5 over 4. What? So it doesn't make a difference, any difference which corresponding side you choose. You just remember, for the smaller one, you're going to put a factor. 20 factor equals 25. And then isolate that F, and you will get the scale. So now I know the scale is 5 to 4. Yes? Okay. Good job. Now scale factor is only linear measure, not volume. You cannot use this for volume. So here we have this beautiful little box that I drew. We're going to pretend it's 2 centimeters